serious. She'll be talking about the maths behind quantum theory. Welcome, Maaike. Thank you very much, organizing committee, for inviting me, and thank you all for being here tonight. My research combines computational linguistics, quantum theory, and mathematics. And tonight I will tell you a bit about this unique combination and how it has prompted me to develop some new mathematics in my deep field. So let's start with computational linguistics. The aim of this subject area is to create a model of language, human language, in a way that a computer can understand it. Think about Google correctly interpreting search queries. Even though Google has gotten quite good at it nowadays, it still makes mistakes. Things like if I Google rabbits chasing dogs, it returns images of dogs chasing rabbits. So it's not quite there yet. And computational linguistics tries to solve this. Specifically, the model that I'm looking at in my research considers the information flow within a sentence. Consider, for example, the sentence, Alice likes blue hats. If we look at the adjective blue, then we see that it modifies the meaning of hat. And so blue can be seen as a sort of function that takes in hat and gives out a blue hat. And in the same way, the verb likes takes Alice and the blue hat and puts that together to form the sentence. Now I can draw this information flow with a usable whiteboard. If we start here at the top with Alice and a hat, so this is Alice, that's Alice there, a figure, and a hat, H. Then blue is a function that manipulates the meaning of hat, and it gives out a blue hat. Blue hat. And then finally, we have a box likes. So this was the box blue. And likes, I hope you can read this at the back. That's likes. Takes Alice and the hat and produces the sentence Alice likes blue hats. So this is a sort of the information flow of this sentence, and we can draw such a diagram for basically every sentence. But how does it help a computer? A computer can't read diagrams. But what a computer can do is mathematics. And to bring the mathematics in, we will take a short look at quantum physics, or just general physics. Because if we take this diagram and remove all the linguistic information from it, and just keep the boxes, like so, then it could describe really anything. It's just a general information flow thing. So instead of language, it could just as well describe two particles. And then one of the particles is accelerated and smashed into the other particle, and a third one comes out of the experiment. It could just as well be that diagram. And the neat thing about physics is that physics computes everything with mathematics. In physics, particles, the inputs, are just a list of numbers. If I want to describe my position in space-time, I use 4 numbers, 3 coordinates for space and 1 for time. If I want to describe the color of this pen, I use the number that represents the wavelength of the light that it reflects. So in physics, everything is captured in numbers, specifically lists of numbers. And then the experiments we do to them, the way we manipulate them, we can capture that in mathematical functions. So that in the end, if we know the list of numbers going in, and we know what the functions do to the list of numbers, then we can compute the outcome. Now, wouldn't it be nice if we can use this same mathematics in the linguistics? And it turns out that we can. There are linguistic models that capture the meaning of a word in a big list of numbers. And it's only a small adaptation for this model to also capture adjectives and verbs and other non-noun words as functions. So from this model, we can actually build lists of numbers representing the nouns, capture the functions that manipulate those nouns, and finally compute the meaning of a sentence. And that's exactly what a computer needs. This is something a computer can work with. But of course, this is a very simple sentence, and language is a hugely complex and creative thing. So what I'm doing in my research is I'm looking at two specific phenomena. Those are homonyms and hypernyms. Homonyms are words like bank, which could mean either river bank or financial bank. And hypernyms are words like tree, which is a general word for an oak, a den, and a palm tree. As soon as I say I saw a tree or I went to the bank, you don't know which bank or which tree I meant. So we don't know which list of numbers we should use there. It's a sort of, we can come up with a probability distribution over the list of numbers, but a probability distribution is also a list of numbers. So we have two lists of numbers, and to be able to handle this, we take a look at quantum physics again. Because in quantum physics we have these lists of numbers, and in quantum physics there's also a lot of uncertainty. And the way mathematically they handle that uncertainty is using a big complex mathematical thing called a density matrix. It's not really important what it does, but it's exactly what we need in language. So we just borrow that as well, and we bring it into the language. And then we can model either homonyms or hypernyms. And it turns out that it works. It has been fed into the computer, a model has been made, works perfectly. But now the question is, some words are both. So a word like club is a homonym. It could mean a dancing club, somewhere we could go to after these talks. Or it could mean a big pointy thing I can hit someone with. And both of those are hypernyms. The dancing club, which one? There are several in Oxford. And the stick I can hit people with, or things with, it could be a club that a caveman uses, or a golf club. And then which golf club? So to model this sort of dual aspect of ambiguity in the word club, we need something more than just the density matrix. So we look again at physics. Is there anything like that over there? But this time there isn't. Physics doesn't have this sort of dual ambiguity thing. So that's where new mathematics needs to be developed. And that's what I'm doing in my research. I'm generalizing these mathematical objects used for one kind of ambiguity in such a way that they can capture both kinds at the same time. And yeah, that's what I do.